Okay, as I told before, it will be a workshop and hands-on thing. We will introduce you Arduino through using a proximity sensor and the LED. So.
How many of you know Arduino?
Yeah. This is
only the name, or? Just read about it. Okay.
Okay. Actually, we will start by them.
Yeah. I mean, let's just briefly introduce Arduino. Arduino is like a microcontroller. Is now the standard in education because it's very much easy than other platforms. That's why they became really popular. There is a lot of other microcontrollers in the market, like for example, like Texas Instruments and these kind of companies. But well, Arduino, let's say that until recently was all based in Atmel chips. Recently, is not really true anymore because they also have ARM processors in some of the versions. But yeah, the thing is that differentiate Arduino to the rest of the microcontrollers is like it's super easy to make things, and it's super easy to start, especially for a software developer that doesn't have a knowledge on electronics. There is also a lot of things that you want to learn. That is like, for example, there is shelf of Arduino that basically are just like things that plug in top of the Arduino that can do many things, like shelves that drive motors, shelf that has Wi-Fi, like the other presentation was saying, like a shelf that does the Wi-Fi module. And we don't have any shelf here, I think? No, we don't have any shelf to show, but there is plenty of examples in a SparkFun or other fruits. There is several companies that they helped build their business model on top of Arduino. Basically, companies had a shelf for Arduino. Well, we can show actually.
Yeah, but let's show the documentary.
Okay, yeah.
I mean, I think the Arduino is one of the most known open hardware, and they also have done a documentary about the story. So we show you, it's 40 minutes long, so we just show you the trailer, but if you are interested, you can look up and watch the whole documentary on your own. I think it explains.
I heard about this Arduino project and I saw it online and I said, wow, a lot of people are starting to talk about this. I should check it out.
Because we wanted to make a tool for our student that was more modern than what was available on the market at the moment.
For me, it was a case that this is a tool that I could see using myself, and therefore I could believe in actually helping to get it out to a wider world.
El hardware abierto significa volver a tener la posibilidad de mirar qué hay dentro de las cosas.
We wanted it to be open source so that everybody could kind of help and contribute.
For me, that's really about giving people the information they need to recreate the piece of hardware for themselves.
I'm really passionate about Arduino because I really care about understanding more about how the world works.
Mark Weiser said that there will come the day when there is more computers than people. If every computer had a keyboard and a mouse and a screen, it would be impossible to command our lives.
And we started to figure out that there was a way to get a very nice ecosystem of people participating and making extensions, making derivatives and helping.
So it's kind of like I'm taking one step up a ladder, and then
I think
internet
connection
well,
is not
anyway, before it's loading more, I mean, this is the Arduino board, and it's basically this big, well, this is the Uno, which is pretty much similar to the first Arduino that was released, the Guljajeva. And basically this is the big chip Atmel. Like now the recent ones are like a square and a small. But actually we like these ones because you can unpin these ones and you can make a PCB, not SMD, that we can still build with our own hands and plug it there. I mean, the secret of an Arduino to jump from a prototype to a real board is amazing because basically Arduino is a bootloader that boots in this Atmel chip. That's what Arduino core is. And then all these PCBs actually mainly for testing because stop. Then we.
So we had to simplify.
And because
and that's the
basically you can build a basic of an Arduino
computation.
Oops, sorry. The basic of the Arduino is basically the Atmel, the crystal, and a capacitor. And this is with this you can build an Arduino. And even if you take out the crystal, you can go to 8 Hertz natively without the crystal is 16 Hertz. Means you can do PCB and then put the Arduino and make a native Arduino shelf without an Arduino. We do actually in our art projects, we do our own PCBs and we prototype with Arduino, and many times we just take the Atmel, put load the Arduino, and just don't use all this Arduino thing. Because if you don't need the USB, it's way cheaper. The Atmel chip is just like $2.50, and then the crystal is almost nothing if you buy in a good amount, and the capacitor is also nothing. Yeah. It is great.
I mean, the advantage of open hardware, especially in case of Arduino, it gave, it really was kind of brought the wave of innovation in this field, I would say. But, okay, now we get really practical, like we were asked. And actually we thought there would be 10 participants, but the hall is full. So
well, we have like let's see how many Arduinos.
Well, we have 10.
10 Arduinos.
So, but well, you can pair up or triple up, or I don't know, take in the groups. And well, we have put the instructions and the example code on our GitHub. So if you go to or if you search for Varvara GitHub, you should get to the link, and you can open the instructions and Arduino.
It's not a very complicated workshop. It's just like that you know how to upload a code, and you start with it, and then later on you can buy one at home. You can continue doing many Arduino projects. And well, a very important thing is that Arduino is open hardware, and there is tons of code, and there is tons of shelf. There is a community around Arduino that that is making happen many things, and you don't have to reinvent the wheel in any area that you will bounce probably.
Okay, the first thing when to use Arduino, you have to download the environment of Arduino. So you go to Arduino web page and you go to downloads and you choose your operating system. So this is the first thing what you should do in order that we can proceed in the workshop. Otherwise, or unless you have it already.
Yeah. Let's say that now when we call Arduino, there is not only one board of Arduino. Now there is, I think, 10 models of Arduino, or even more. This is the Arduino Uno. In the first page, it was the Arduino Jung. That is the last one that has Ethernet and Wi-Fi built-in and its ARM processor. There is also the Arduino Mini, which is like called Mini is because it's small. There is also Arduinos that they sell out of with these headers to connect right away to the PCB. It's a lot of variation of the Arduino, but the good thing is that they all work with the same code. Means if you have a code for Arduino, it will work in any platform of the Arduino boards. Well, if you don't bounce into some problems that you basically put a PWM like for driving a servo motor, and you put in a pin that in this board doesn't have a PWM, like.
And also be careful with Chinese versions.
Yeah,
they function a bit different.
These ones are original Arduino. Nowadays, they're also clones of Arduino. To be honest, like there's also the clones. There are clones and they kind of work, but there's some you can get some surprises as well.
Okay, we have here the 10 boards and 10 sets. So who is participating? Please. The first 10 get served, basically.
Yeah, you need a
Yes,
computer.
you need a computer without.
You need one of those. One sensor.
And
one
please return them later
please.
because these are not the Christmas presents,
Yeah,
unfortunately. So
sorry. I think someone left without the
take
cable.
Yeah. Who took and without the cable?
You left without the cable.
I have. We still have more.
Who left without the cable? I think someone. Yeah, you left without the cable.
So here you go, the set. Someone else will be.
There's still 3.
Yeah. So, yes.
I know, still some more.
So, yeah. Wait. This is shorter. I think this is better for you. Here we go.
Do you have the IDE in a zip drive or in a...
Sorry?
Because I'm trying to download it, but the connection is too slow.
If connection, maybe if you go out for a second, it will be faster. Do you
have like a Windows or
Mac?
Mac. I might have. Do you have a USB? No.
I would suggest just go for a minute out, and you will get much faster the program.
But you want one or? Okay. There is any more?
Yes, there is more.
There is the last one if someone wants.
No, I think we have even more.
Okay, no, there is 2 more maybe.
Yeah, wait.
Anyone want to try as well? No? No more people? Okay.
Some more? No?
No.
No, I think you had more. Yes, here is more actually. Okay, if no one else.
The first thing will be to download the Arduino software that is for uploading any Arduino software to the microcontroller. It's this kind of blue
well,
screenshot.
This is the environment. If the download goes very slow, I suggest you to go to the hall one moment because here I don't know.
If someone has a USB, I have downloaded the Mac and the Windows. I can give in some USB, but I don't have USB.
So.
I thought that Tallinn has a great Wi-Fi everywhere.
Not Vir.
But not here, looks like.
I think they cut it here that the participants cannot use Facebook or something. Yes, you should.
We can explain something.
No, están haciendo. If someone needs assistance or has questions, just let us know.
I mean,
this is you can open your Arduino and show that the.
No, it doesn't. Go. Like before, I was saying there is companies that build things around Arduino. For example, one is SparkFun. They are big in Canada, and basically they do shield for Arduino, like many kinds. Actually, there's every year they double their income, I think, because they're very successful on doing things. Like you can see, like they have like many little PCBs that will connect to Arduino, and they have the code for each one. I don't know, we can go to. And the other one, the other company who does similar thing is Adafruits.
But I think. Is that? ¿Estás en Windows?
¿Eh?
¿Estás en Windows?
¿Dónde?
You're in Windows.
Ah, no. Well, you don't need to. Okay, change the... Anyone managed to download Arduino already? Ah, okay, great. Then
great.
let's go to the Arduino.
So the first thing is to check if you have all the drivers right and Arduino recognize your board.
Yeah, you have to download
Well, I think you have
the
to
driver,
mirror
the
screen as
Arduino FTDI. This is the environment for coding and uploading to the Arduino board. Well, nowadays there is actually other ways to send to the Arduino. I use, for example, a lot the Sublime, the editor. I use a bundle of Sublime for uploading to the Arduino. I can show later as well. It's quite comfortable. Well, I had a problem with my Retina screen. It didn't get support in Arduino for a while. Means I moved to Sublime to upload. Well, and I love Sublime. Means I keep using Sublime.
Okay, for the ones who has already, sorry, I'm behind this poster. No. Talking from behind the poster. Who has installed the environment? Basically, you have to look first which board you have. Most of you got Uno, but maybe you have some different one.
I think there was one Mega. Someone
Mega
had
also,
a
yeah.
Mega.
Ah, okay. Someone is already blinking there. Good.
Yeah.
So here, basically, you see how many boards Arduino has, and actually they have more. So it's always you have to choose the board what you are using.
Plus, and then there is ground. Means
you have
one
to
in ground and the
also
other in
select
plus.
the serial port.
This goes to...
And if you don't see the serial
look in
port
the
and your Arduino
settings
is connected, then it means you don't have the drivers right installed, or you don't have, or you haven't installed the drivers. So you have. This is kind of the key to start. From Arduino also as FTD. Well, it comes with Arduino actually. The environment, FTDI drivers. I think. Wait. Is it no?
If no, I...
No, but here it's, wait. Here, normally it comes with Arduino together, but I can also search.
FTDI driver.
Yeah. Wait.
Well, I put the link here.
Yeah, I put the link
you
here,
put
yeah.
it.
Yeah. So, as I recommended also from our GitHub, if you get the instruction file, there are all the instructions also.
Well, actually, the Uno has, you can plug the LED, or you can use the LED that is built in the Uno here.
Yeah.
This is in the 13 pin. The 13 pin is kind of special in the Arduino because it has a built-in resistor. In theory, if you plug a LED into a microcontroller, you have to put a resistor, but in the 13 pin is already installed. Means you don't need a resistor.
Okay. Can everyone see the Arduino serial ports? And
Yeah? He's still downloading?
To download. Yeah, you want to download.
And you didn't manage to? Downloading.
Okay.
You're downloading still?
Yeah.
Oh, yeah. How is it? Some people went fast, others slow?
Now, if you go out from this
yeah,
room, it goes... Oh, really?
Worse now.
There are too many people on the Wi-Fi. Yeah.
You're
ready with the sensor?
But we don't have an environment that is Arduino IDE effect.
Crash?
You know, in the morning I tried Yun with the latest beta.
Oh yeah.
IDE. The IDE sucks actually.
Yeah. Well, I have to try still the Jung.
But I love Arduino really. I have those
Ah.
tapes everywhere in my videos.
Well,
But I used to use Visual Studio actually to write the code.
okay.
It's possible. Then
Yeah, and then you send.
intelligence and everything is available.
To destroy Arduino board.
Does it work or not? Yeah, this is the right.
Here was a question: how easy is to destroy an Arduino? Well,
Well,
it's an electronic piece. Means if you will shortcut, you start to shortcut things, you can destroy.
So pins are connected directly to
Yeah, the first thing is like,
well, there
okay,
are some
the
protections.
good practices in the Arduino is that if you are connecting things, the best is to first unplug and then you plug. That's the first thing. It will not happen too much things when you plug things that, like a sensor or something. But if you plug, for example, a motor that has reverse current, and you didn't plug well the things before, like for example, the iode that cuts the reverse current, and then the reverse current goes to the Arduino, you can damage.
Yeah. Well, I think the more trouble you have if you do kind of wrong things is that your computer closes or you have to restart because you are drawing too much current from your USB or something, or you make some wrong connection.
Yeah.
So
Well,
it's
especially
more
when you work with
urban.
motors, you have to be careful.
Yeah.
Look before how much spend is like the consume of this motor. And then the other thing that the Arduino has like a USB. You can power with the USB, but you can power externally. If you power the USBs normally they don't go more than 500 milliamperes, which is okay for example, one motor. Well, depends on the motor we're talking, because if we're talking a motor like this, if we're talking a 5 volts motor, like a servo motor, it will be okay. But just keep in mind that they cannot go higher than 500 milliamperes. In the Mac, if you exceed, you will see a nice window that maybe you didn't see before, that is like the closing button big like all the screen with basically kind of gray. And they say like you have to reboot because you exceed consume in the USB port. And this kind of shut down the motherboard. Means, yeah.
So to understand correctly that in general it's safer than Raspberry, because in Raspberry if you exceed even 40 milliamperes, then it's dead.
Yeah, no, it's
No.
yeah,
The
you have
Arduino
to
is
damage
definitely
completely.
better.
I mean, you have to. It's well designed, but you still have to be careful. I mean, it's electronics, but. Yeah.
I think Arduino is quite good for, I would say you can do complex stuff, but it's very good also for beginners because it is quite easy and it's lots of information like online. Because so many people are using it, so many universities are using it, that yeah, it's amazing actually. And
Yeah.
there are lots of like Mark showed already, Spark funds and other fruits, and lots of other businesses are popping up who are producing kind of extensions or
Then
add-ons for Arduinos,
the next will be to
like
communicate, for example, to
screens or
Python.
sensors, whatever, shields and so on.
And
Okay, cool. So someone is getting.
Then the other thing that is good Arduino is that it's easy to communicate to your piece of software. Like
Another
you can
what?
communicate basically to to any language, like Python, JavaScript. We recently use a lot of Node.js for our projects, and we communicate to Arduino, to C++, Java. Well, it's a serial communication, basically, but they have a lot of examples how to make work the Arduino with many things.
Okay.
And the other thing that is interesting is the libraries. Like here, this screenshot, I don't know if you can see here the line, but these are kind of libraries built in, and there is external libraries as well. And many people is contributing with a shelf and sometimes a library. and then is a little piece of software that then you can import a library in the Arduino, and then you can use, I don't know, else. I mean, here is the liquid crystal, but one project before, like, well, one project that we showed this morning, like the metronomes, it used an OLED LCD, and this library doesn't work with the OLED. Then there is other fruits who release the library for the OLED screens, and basically actually it's really tricky because we were using the normal liquid crystal LCD. It was working fine at the beginning, and then was getting garbage, and you see strange things appearing in the LCD after a while, and then we were like, what happened here? What happened here? And then at the end we found out that basically it was different. It's different screens, and the protocol to speak is similar but not the same.
It's called OLED screen.
Yeah.
OLED display.
OLED display.
So it's different library, and then it works.
But it looked the same. I mean, if the screens you have in the hand, the LCD and the OLED, you can think that it's almost the same, but well, the way it's building is different.
Okay. Someone succeeded to download and do the things? Okay, great.
Well, here in the front, they did everything. Well, not the communication, no, with Python, yeah?
No, I'm not Python.
I'm not Python. No, Python.
You know Python?
I have tried that.
Well, you can use any other software which uses serial communication.
Yeah, if you're confident in
another.
another
If you don't like
language,
Python, if you know processing or Max MSP, whatever.
Yeah, there is a code that that is in the repository that basically you can, if you send a 0 or 1, will light up the LED. Means you can send in the serial port 0, 1, and it will light up the LED. I mean, I don't know if you know a lot about microcontrollers. When microcontrollers, they work normally in 5 or 3 volts, and this chip has, these ones are digital pins, and these ones are analog pins. Well, I can explain now. Someone, do you know the difference between a digital and analog pins? Okay, we'll explain. The digital pins are 0 or 5 volts.
Yeah.
0 or 5 volts. Rather than the analog pins is from 0 to 5 volts. And then the analog pins are used for example, analog sensor. It will give up, like the sensor will be whatever sensor, like a temperature sensor or a pressure sensor or whatever sensor. It will give a voltage that varies with the sensing between 0 and 5. And then you will have to map this value to get the data out of it. And then there is the digital pins that will have digital sensors or digital actuators, no? Like for example, the PWM is doing like a PWM sign, for example, for motors like servo motors, to send the degrees you want with the servo. Well, basically, this is kind of a little bit. In this board, it has the 3.3, like you can see here, and the 5. Means you can use sensors who use 3.3, putting the plus into the 3.3 or the 5. There is like some Arduinos that only work in 3.3. All the Arduino means you cannot use the 5 sensors. In this sense, electronics, the ones that are not very into electronics, is very standardized, the things. Normally the things work in certain standard and they don't change.
Okay.
Who is still downloading? You still downloading? You finished already?
Trying to change the language of the user interface because later I can't understand the student.
Okay.
Oh.
Wow. Good.
If we change polarity, it doesn't work.
Yeah, of course.
Yeah.
Because it's one way. Yeah, the LEDs has only one way of connecting.
Yeah, because they're diodes.
We didn't say which one?
Maybe one shorter, one longer.
Yeah.
Well, the shorter goes to ground, and the longer one is the positive, the 13. And sometimes, very often, if the legs are cut, the easiest also to find out which is positive, which is negative, is the flat side of the LED is always ground. So you can also the haptical kind of knowledge. So this is kind of the basic example of Arduino, just to make the LED blink that you know that the things are working. But also this example, like you can play around with delays, and because you turn high or low the pin, basically you give the energy or you draw it back.
But if you imagine, like, you are now sending 5 volts to a LED, but this could be whatever. This could be a relay that opens the electricity to
Skype, not Skype.
to the lights, or this could be one motor, a DC motor. Like you are sending 5 volts to this pin, and you can control with code, but then you can do many things with this.
Yeah, that's why Mar uses Sublime, because you cannot see.
Yeah, this is what happened with my.
But you can see from.
But before we could see. No.
No, I couldn't. But I want to do the. Well, after the LED, you have also the instructions on the GitHub, or I can explain also you the next exercise is with the proximity sensor, the sharp one. There are some from 5 to 10 centimeters, or from 0.5 to 5 centimeters. I don't know which one you got.
Because you now make a mirror, and then because you make mirror, now both are fucked up. Before was okay. And then
Okay, that's fine. But I cannot see there and here to do the things. And well, the Sharp is quite known for making the distance sensors, and you have quite a big range of them based on the distance you want to get. So I made for you already work easier. So I have soldered the cables and color coded them. So the yellow goes to digital 2. And the red is the 5 volts, and the black is the ground. So when you plug in and upload the code, then when you put the obstacle, or basically your hand maybe, closer, like it gives you the LED feedback of the sensor, but also if you open your serial, you will get the numerical feedback for the what is happening in the environment, so to say. And that's how it's the easy way how to start to understand what is going out outside and map it with a code, so to say.
And before you were saying how to not broke the Arduino or sensors, the first is to be very organized. Like Barbara saying, like color-coded the wires is a good start. Because you start by messing the colors and saying, well, I don't have red, I don't have like black, let's put everything with the same color, and then you connect wrong, and then one sensor you just like burn in 1 second because you connect the ground and the plus, and yeah, some sensors are sensible, some no, but well, there is one golden rule in electronics: if it gets hot, disconnect fast. Because actually there is many things that if it get little hot, it might be okay. If it get too hot, something is wrong. Completely wrong. Means like if you are driving, like for example, like before I was saying, like too much consume in the USB port. If you see like Arduino Atmel getting hot, I can tell you, believe me, that this is the problem. Like when you putting hot the Arduino, it's like you are stressing the Arduino too much with consuming too much. well, that's one of the reasons. It can be many others, but one of the reasons can be this: if you consume too much, like some components will start to get hot. But also, if you shortcut something, definitely something will get extremely hot. And yeah.
Well, this with a sensor like the serial monitor is one kind of the. I think they have. Do you have question or not?
Questions?
The one kind of the.
Did you manage to download?
How you start to basically work is to monitor what values you get in the serial monitor. Of course, you need to make in their code the serial print. And then
With
basically here you are getting the digital distance sensor values.
Take this one.
Like if it has no obstacle is 0 and when it is detecting something is 1 basically.
Yeah.
So this is kind of the easiest way. And then kind of the challenge of the maybe of the workshop is to that you can use either the Python or whatever software you want. Yeah. Okay, cheers. And make basically either the LED blink or get the values from the sensors to your software.
No. You have.
If you don't know how to do it, you have a code in our GitHub and also in the instructions you have.
Well, I can stop like this.
Well, in Python you can do it basically.
Wait, first
with the 4 lines.
Okay, uno. That's good. Okay, let's do this.
And I would say for prototyping, it's very useful environment. It's very fast. You can make things work.
Now. Don't upload it.
Okay.
And then, well, you can. 1. 0.
Okay.
This is the serial monitor.
So you can now speed up because our time is
the serial. You have to define the speed here.
Out.
And
we have 2 minutes, I guess.
In any language, you have to say serial and then the speed that you start, and that's it. Actually, there is
How is the process
in Python. Maybe you don't have time now, but you can do later. It's kind of easy.
This you connect to Arduino board.
This is just one
the yellow one goes to
this is just one kind of sensor, but you can use many kind of sensors.
Yes, it's
you can see. Always good if you do like this.
This is sending 5 volts, and this is looking if here is 5 volts or 0 volts.
This is plus and minus. This goes here, and then you connect. And of course, you need to upload the new code for the sensors that you get. Yes.
Here.
These sensors are really much used by the robots, for instance.
Input,
also.
other pin mode
output.
I will explain that. Just one question that there.
Yeah, well, quite. Yeah, actually, you can modify. Like this example is actually, I think you take the push button one, for instance, and you modify how you want. I mean, yeah, they are.
There is
an
example in this environment. Like
yes.
Like the example of the sensor and the LED.
Yes.
It was here one question like, how you define that the pin is reading or is outputting? Well, it's in the setup.
Yeah.
You say like pin mode, and then this is the number of the pin, of the digital pins. Actually, the one number that is in the board. Write it, and then you say input or output. Then how you read is here in the digital read. You say the number of the pin, and then here we'll receive if it's high or low, 0 or 1. And if you want to output, it's digital write. And here is 0 volts. If you say low, and if you say high, is 5 volts.
Yeah. And sensor state, from you see from the serial monitor. Okay, we get the sign this. It means we see you on the next session. Yeah, this is. I guess it's to get like. I hope you got understanding of what is Arduino. I think for kind of proper. When you spend some days on it, then you get.
Yeah, and there is a lot of documentation on the website. and a lot of tutorials for example, SparkFun, the website that I was showing, that is a company that builds things around Arduino, is doing tutorials all the time in the blog, featuring all their shelf and actually even just Arduino things, because they sell them and they are spending some time. And Adafruits is also doing the same. They have a team of people doing just YouTube tutorials of all their products, and yeah, it's very good because there is a lot of information of the thing, and it's easy to use, like you saw here. Okay. And yeah, this can open you other opportunities to use software in a hardware things.
Okay, if you kindly bring back the material.
Yeah, the Arduino, no. I took it before. The Arduino here, I took it before.
You took the Arduino.
Ah, okay, yeah, good.
Yeah, you took from us.
I took from you?
You started to like it.
I started to like it. Nice.